So welcome to this lesson. We are going to deal with the topic of Form 2, Statistics 1. And to our definition, we define statistics as a science that deals with collection, organization, presentation, and interpretation of observations or data. So we are going to consider scores of 20 students in a maths test. When the scores are listed as below, they are not meaningful in the way they are. So we normally have to organize the data so that we can move on to the next process of presentation, interpretation, and then we can make decisions using the data as it comes out. So organization of data, we are going to organize, and in this group we are going to call it grouping. We can group this one into classes. And for example, the classes that I want us to use for now is a class width of 10, and a class of 10, starting with the lowest class. The lowest value here is 24. So if I'm told to organize this data from a class, let's say 20 to 29, then I can move on with having that interval of 10. So if you can count 120 to 29, you are going to see there are 10 intervals. So I've organized this one in this way. So how we deal with this is we are going to do the organization of number of students who scored within a certain class, and then we get the frequency. So the best way to do this is to come up with something we call a tally. And we are going to see what each class has. So I'm going to take you on how we do a tally. For example, the first set of mark here is 70, and therefore we go to this class which has 70, so we list 1. The next one is 48, which is between 40 and 48. Then we have 72, so you can cancel that way. Then we have 56. 56 is between 50 and 59. Then we have 75. We have 69. We have 84. 78. We have 66. 37. Then we have 84. We have 74. So when we reach the fifth number, 1, 2, 3, 4, the fifth one, we do that to show that that's a set of 5, 5. Then we have 49, we have 68, we have 24, we have 55, we have 81, followed by 45, 86, and then finally we have 30. So with this now, we can now confirm our frequencies. And our frequency, we count now what we have got from this. So in the first one, the first class here is called, we have 1. We just do the counting. This will be 2. Then this goes to 3. Then we have 2, 3. Then we have 5. And we have 4. And remember, this one should also add up to the set of data that we were given. So we had 20 students. So when you add this one, so we are going to have this one as 20 items. So we are going to see other cases where we organize this data. But grouping, the best way to come up with a group of students, you come up with what we call classes. And these classes are going to give us from the lowest to the highest. Normally, a question will tell you how to organize this. You can be told 5. In case it is 5, we'll have 20, and the highest value will be 20, 21, 22, 23, 24. So, in case you are required to have 5, class interval 5, then that's what you do. Then the next one, class interval 5, will have 20 to 24. 25 to 29, 30 to 34, 35 to 39. You move that way all the way to where we are going to have 84 to 89. And you can also develop your own table for these 20 values. We're not only saying that there need to be 20 values, we could have more. It's only that this one was having a small section with this, and you can develop this one to have more classes. The next thing that we are going to look at is what we call, we'll come back to this again, is what we call measures of central tendency. And these are measures that I'm sure you have heard of this tendency. One is mean, the mode, and the median. These are things that we have heard of. So the measure, we call them measure of central tendency because they go to us to move to a certain average. So the first one, we call it a mode, and a mode is defined as the observation with the highest frequency. So when you look at a set of data, we can get the one with the highest frequency. So, or one that is appearing many times. So in this data, for example, what is the mode of? The data starts from 11, we have 16, 13, 18, 15, 16, 21, 12, 16. So 16 is repeated 3 times. So the mode for this one is 16. The next one, we have 20, 21, 21, 17, 22, 19, 17, and 23. Looking at this one clearly, we are going to see that 21 is here and also 17 is here. So the mode will be 21 and it can also be 17. So this is a bimodal kind of data. So it has twice. Then we have what we call the median. And the median is the middle observation, the one at the center. So using the same data, we can form we can arrange this data into either ascending or descending and then get the middle term. So let's start with the first one. We start with the smallest to the highest. So this one is going to give us 11. We have 12, 13, 15, 16, 16 again, 16, 18, and 21. This 1, 2, 3, 4. There are 9. 1, 2, 3, 4. Yes. Now from this one now, we now look at the median. We can start with this side, move this way until we get the one that is at the center. And we are going to see the median is 16 for this set of data. Then the next one, again, we can arrange and get the median. This is when these were 9 terms, so the 5th item becomes the one at the center. So we also have 20 to 23, so we organize this one again from the smallest. So these are even numbers, so we have to look at how the median will be formed, and we are going to see the median is between 20 and 21. So here you say 21, 20 plus 21 divided by 2, and the median for this one gives us 20.5. So then we'll have to deal with the median, the mean, and mean is an average, and mean is an average of the total sum of all data values divided by the number of data values. For example, now we can take the first one, we get the total sum, and the total sum of this one is going to give us 16 plus 11 plus 16 plus 13 plus 18 plus 15 plus 16 plus 21 plus 12 plus 16. If we get the sum total, then we are going to divide by number of items. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 items, and the mean will be given by, so we have 11 plus 16 plus 13 plus 18 plus 15 plus 16 plus 21 plus 12 plus 16. And this one is going to give us 138 divided by 9, and this is going to give us 15.33. So to ensure you are also accurate, you can confirm again. Yes. So for us to get the mean, we say sum, and the sum in this where we are going to say x mean is defined by mean, we denote it by x bar, and then sum we write it that way, of x divided by number of terms, where x are these numbers or data values that we have been given. So the next thing we are going to look at is how, when we are doing organization of data, I want us to come back to this. When we are doing organization of data and we consider this, so the first thing we have is to define is the class limits, and the class limits are given by, so the limits are these ones that we call 20 to 29. Those are limits, and 20, these ones on this side, we call them the lower limits. And then 29, 39, 49, 59, 69 to 89 are called the upper limits. So the limits are the ones that form a class. Then from there, so we have limits as 20 to 29. Then we have boundaries, and boundaries are formed by, since this data is continuous, we have some gaps here between 29 and 30. So therefore, we normally subtract 0.5 to the lower limit and add 0.5 to the upper limit. So we'll have, for this class now, we are going to have 19.5 to 29.5. Then we'll have 29.5 to 39.5, 39.5 to 49.5. And we can move all the way to 79.5 to 89.5. Those are called boundaries. The boundaries. So there are some classes I have skipped here. So the boundaries. Then we have the class width. The class width, or what we call the class interval. The class width, or what we call the class interval. So an interval between this class that we are having, for example, 20 to 29, by counting from 20 to 29, we are going to get 10. So there are 10 intervals between this class. So how easy can we also get it? We can use the boundaries, for example, to say 29.5 minus 19.5, and this will give us 10. We can also take another class. For example, we have 50 to 59. So for 50 to 59, then we are going to have boundaries as 49.5 to 59.5, and therefore we can get the difference between this one, and we are going to get 59.5 minus 49.5, so which will give us 10. The next important thing to know is the class mark, or the mid mark. The mid mark, also called the midpoint. How do we get it? So from our classes, for example, now we have 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69. So we can have our midpoint or mid mark, and our mid mark is going to be given by the sum of the class limits divided by 2. So we have 20 plus 29, you divide by 2, we get 24.5. You can also take 30 plus 39 divided by 2 to get 34.9 and 0.5. And you can get the others. All the way to 84.5. We call that the class mark. They are going to be very useful in our calculation. So we have the class limit, and the class limit we have said we get it from the class 20 to 29. 20 becomes the lower class limit, 29 becomes the upper class limit. We have the class boundaries, which I have said we form them by subtracting 0.5 and adding 0.5 to make the classes continuous. So we have 19.5 becoming the lower class boundary and 29.5 becoming the upper class boundary. Then we have the class width or the class interval, the interval between the lower limit and the upper limit, or between the boundaries. As you have seen in this class, we are going to have 10. Then we have the mid mark, and the mid mark is given by getting the sum of the class limits and dividing by 2. Also, the class boundary can give us the class mark, which is also called the midpoint. So, and midpoint is normally noted by x. So we are going to see on the use of data how we now calculate by now using a grouped data. The one we had here, this one is called ungrouped data, and that's how we use ungrouped data to calculate the mean, median, and mode. So data is, when it is grouped, it is in this form. So we are going to use this data in this form so that we're able to get the mean, median, and mode of class and mode frequency. So we proceed with group data, and the first thing we are going to look at is the mean. So we have an example here. Find the mean mark of the following frequency distributions. So the first thing to do with the mean, we have already indicated that formula for the mean is given by the sum of fx over summation of f. So the sum of fx, so the first thing we need to identify is x. So with this one we can create another column here and call it x. This frequency we call it f, and we have said previously that x is the midpoint or the mid mark, and the mid mark will be given by the sum of 41 plus 45 divided by 2 give us 43, and then we have 46 to 50 will give us 48, 51 and 55, this will give us 53, and this will give us 58. So we already have f, we have x, so we need the product of this, the product of another column here, fx, and fx means we multiply f by x. So we have 22 multiplied by 43 give us 946, 55 multiplied by 48 2640, 93 multiplied by 53 give us 4929. We have 58 times 30 will give us 1740. So we need the sum of fx, and the sum of the fx is a total of 946 plus 2640 plus 4929 plus 1740 to give us 10,255. This is the sum of fx. Then the sum of f will be 22 plus 55 plus 93 plus 30, which will give us 200. So the mean, which is x bar, will be given by the sum of fx, which is 10,255 divided by 200. And this will give us 51.275. So the mean mark for that question is 51.275. So the next thing we normally calculate is what we call the median, and the median is calculated by using a formula. We have already covered and group data. So when we are getting a group data here now, we create what we call a cumulative frequency. Cumulative frequency so that we'll be able to get where the median lies. So the first thing, up to 2, we have 2 for the first class. Then we'll have 2 plus 14, which is 16, and this contains the 2 plus the 14. Then we have 16 plus, this will give us 36. Then we have 36 plus 12 to give us 48. 48 plus 8 to give us 56. And then we get 60. So if these were items we are arranging, so item number 1 to 2 are in the first class. Items from number, or these marks from person who got 3 to 16. And then we have from 16 to 36. If we were to arrange, so 16, 37, so this would be 17, 37 to 48, or even now we get 49 to 56, and then we have 57 to 60. We can also interpret it as those people got 9 and below, 0 to 9, 2, 16 is 19.5 and below, and here we have 29.5 and below got these people who are represented here that way. But since we are looking for a number median that's going to divide by 2, we can apply this. We need to know 60 since it's our total frequency. The CF, the last one, should be able to add up to this. So 2 plus 14 plus 20 plus 12 should give us 60. So 60 divided by 2, this will give us 30. And since this data is continuous, we are not going to calculate at 30 and 31, we only calculate at 30. So that can be identified between these ones. They will help us to know where that is. And that is between in the class interval of the class cumulative frequency with 36. So this is where we pick, because 17 to 36 are in this class, so we pick this one. So we have a formula for that. So we say median is equals to median is calculated as lower class boundary plus n over 2 minus Cf over frequency times class interval. So L represent lower class boundary for the class. Lower class L is lower class boundary. Then N is total frequency. CF is cumulative frequency of the class before the median class. And then we have frequency, which is frequency of median class and we have I, which is the class width, and we have to call this one class interval. So we're defining the class boundaries. So we identify one, the lower class boundary for this median class, and since we have 20 to 29, so the lower class boundary will be 19.5 plus n over 2, which is 60, divided by 2, we have found it is 30, so 30 minus cumulative frequency before or above this will give us 16. So F is the frequency of that median class, which is 20, and then we get the interval between 20 to 29, those are 10 items. So this will give us 19.5 plus 14 over 20 times 10, and this will finally give you the median as 26.5. So this is the formula for the median. So lower class boundary n over 2 minus Cf over F multiplied by the class interval, and that's how we calculate the median overgrouped data. So let's see. In this example, we are told to calculate the median, the mean and the median of this data. So again, for mean we need x, because our formula will be sum of fx or summation of f, total f. So we can get x, and x we said is divided by, is the mid mark, so 0 plus 4 divided by 2 will give us 2. This will give us 14, 7, 12, 17, 22, 27, 32, 37, 42, 47. So we'll need a column for fx, and this will be the product of this, which will give us 2 in the first one, 28, 72, then we get the total. So this will give us 1120. Our total frequency will give us 50. So we also need the CF and the cumulative frequency so that we calculate the median. So this will be 1 plus 4 to give us 5, 5 plus 6 to give us 11, 11 plus 7, 18, 28, 40, 46, 48, 49, 50. So for us to calculate the mean will be equal to sum of fx, which is 1120 over 50, which will give us 22.4, and median, since these are 50 items, so we look at where 25 is, and 25 will be in this class because this class contains 19 to 28. We have to rearrange those numbers. So lower class boundary will be 19.5 plus 25 minus CF above or before the class. The interval is 10. No, the class frequency is 10. Then the interval from 20 to 24 will be 5. So our median will be 23.5 becomes our median. So we also want to calculate for this. So when you are given your data in the form, now the horizontal form, the best way is to rearrange it to a column form so that you have marks. Here again we are calculating mean and median, so mark 0 to 10, 10 to 20, so we can start with our mid mark here to give us 5, 15, 25, 30, 35, 45, so that we bring out the frequency. So we have 5, 8, 15, 16, 6. So fx, and then we shall have cf. So here you have 25, 120, 25 times 15, 375, 35 times 16, it was 560, and we have 45 times 6, it was 270. So the total for F will be this will be 50. So we get the total sum 25 plus 120 plus 375 plus 560 plus 270 should give us 1350. And for cumulative frequency we have 5, 15, with 5 we have 13, this will give us 28 plus 44, then we will have 50. So mean x bar will be equal to 1350 divided by 50 will give us 27. Median, identify the median class at 25. This is going to be our class. So here we need to be very careful with the lower class boundary. The lower class boundary in this case is 20. Remember this class already crossed 0 to 10, 10 to 20, 20 to 30. So the class is continuous. So lower class boundary is 20. So in this previous class, this class was not continuous. From 19 to 20 we had a gap, so we normally introduce 19.5, 19.5 to 24.5, and this was 14.5. So this one becomes the lower class boundary for this. So that's why we normally make this class continuous. In this class it's already continuous, so it remains as 20 plus 25 minus CF above, which is 13, over the frequency of that class 15 times interval, which is 10, and this will give us the median will be 28. The median will be 28. So let's be careful with such tables. When the table is already continuous, we don't have to make it continuous again.